Hi everyone, and welcome to today's webinar. My name is Richard Funnell. I'm the Global Training Manager at Luxion, the makers of KeyShot, and today we're going to be talking all about KeyShot textures and labels. So thanks to everyone who signed up for this webinar. We had a lot of questions come in about what you guys wanted to talk about and wanted to see. So this is going to be a pretty action-packed webinar. We're going to cover a lot of different topics, and this one focusing in, again, on our textures and our labels. And everyone who's checking in and the questions, thank you very much. As you have questions throughout the webinar, please feel free to type them in. We've got a lot of staff on hand to answer questions as they come in, and we'll also save some time for Q&A at the end. But let's go ahead and take a look at our agenda. So today we're going to be focusing, yes, I set it to show. Okay, how's that look? Perfect. Okay, sorry about that little mess up there. But if you can see it, yeah, so today we're going to be talking about textures and labels. So first we're going to go through some slides that we've prepared that actually help explain the content a little bit better, or at least in more of kind of a visual form. And then we're going to have our kind of hands-on time and then go through all of the content. So let's start off. And let's talk about, what are textures. So textures in KeyShot are generally going to be images that define some sort of specific material properties. So in this case right here, we've just got a simple chrome sphere, no textures on it, and it's sitting on top of a ground plane. And that ground plane actually has a material applied to it. So we're using images in order to define something on that material. We can use them to define the color, for example, or the way the light bounces off of them, or things like roughness. Textures are not materials, they are a property of a material. So we use a texture to define something, either a slider or a checkbox or some sort of value in the material itself. So in this example, again, we've got our simple chrome sphere and it's sitting on top of a metal material. And we're using some really nice textures in order to define the appearance. So especially down here where you can see those really interesting reflections, we're using, in this case, roughness, which is a new type of texture for KeyShot 6, along with the color and the bump to give it more of a realistic appearance. So it's a very broad generalization, but in KeyShot, again, primarily they're going to be images, and we'll talk about the different types, and we'll go through that. Labels in KeyShot are going to be similar, but a little bit different. So something like this, as you can see here, labels are applied on top of a material. So we have some sort of parent material, whether it's plastic or paint, glass, you name it, and then we can put a label on top of it. In KeyShot 5 and prior, labels were pretty much just stickers that you could apply to something. Now they're going to be much more powerful because we can do a lot more with them. So here you can see we've got a parent material of plastic, and then we have a label on top of it. In KeyShot 6, the labels have gotten much more powerful because we can assign, and by default they have a material assigned to them, and we can also texture them. So here's a quick example of just kind of a default scene here. So we've got a calculator. This scene is going to be made available to download as well if you'd like to try it out. So this calculator right here, it's just got some kind of default materials on it. We have a wood texture and it's got some labels on it. We'll run through this exact example here a little bit later, but here you can see that we've added bump and roughness textures in order to make those materials and the labels more believable. So things like the printing on the buttons actually has some form to it. That wood is being defined a little bit better. Had a lot of requests for wood materials, by the way, so we'll definitely be addressing those. But again, those labels are going to be a little bit more powerful. So just some sort of brief intro, right? What are procedural textures? That's a question that we get pretty regularly. Procedural textures are not image-based textures, so they're going to be a little different than what you're used to working with if you're used to bringing in PNGs or JPEGs in order to define the texture itself. So these aren't going to be image-based. They can behave like an image, and we'll talk about that, but they're going to be really math-based. They're like vector artwork. They're infinitely scalable. They're highly adjustable. So we'll go through a workflow working with those procedural textures as well. They're broken up into two main categories, and again, we'll readdress this, but there are kind of 2D textures that follow the same kind of projection types that our image textures do. Additionally, we've got 3D textures. So these are going to be the textures that are completely seamless, and we'll show some examples of that. Actually, yeah, I've got a good sample coming up right here. So in this case, we've got the same models, or the same model patterned in the scene, and we've got it applied to this cool little rhino model. The image on the left, or the model on the left-hand side, is using image textures. So these are kind of our standard traditional image textures, and the one on the right, that's procedural textures, these math-based textures. So as you can see up here, and it's a little bit tough to tell, but in the scene it definitely exists, we're starting to see that the image textures are showing some seams. And if you've ever tried putting a 2D texture onto like a highly organic form, then this is probably going to be something that's familiar to you. So again, 2D textures, your limitations are how it applies onto that piece of geometry. Whereas a 3D or a procedural texture, or in this case it's actually a 3D procedural, this is completely seamless. If you take a look at the surfaces, then that wood is actually mapping completely around the surfaces in a totally seamless way. So yeah, so that's just kind of a quick primer. Basically, think raster graphics versus vector graphics for your textures. Another question that we get pretty often, and we'll get into it as well, is what is the material graph? So in this image that I showed earlier, we have the KeyShot logo applied as a graphic onto this material. But behind the scenes, what's happening is we're using the material graph, which is a node-based material editor, to make some changes to the materials and textures that we've got. So this is a good example of kind of a layered material. We've got some kind of two metal textures and one that's diffuse, kind of the paper backing. We'll run through something like this as well. But this is a good example of how we use the material graph to get more control over our material. And at first, it can be somewhat intimidating. And I definitely, when I saw this, I was like, oh man, this is going to be crazy. But the more I tended to work with it, the more it makes sense. And it's a great way to add more control to your material. The material graph will also let you do kind of layered materials. So in this image right here, we have a glass material. It's actually a solid glass, or maybe a dielectric, and it's covered with two layers of metal, one that's kind of green, one that's kind of blue. And then we've used textures in order to define the visibility on those. So we basically have metal spots in two different colors, both with their own bump textures on top of a glass material. So again, it can allow you to create more advanced materials where we're basically starting to layer materials. Same with this image here, is this really nice teapot rendering by John Seymour. This is using the material graph in order to create more control over the materials. This is using a procedural texture called occlusion to define where we're actually seeing some of that copper color shine through. So it depends how much time we've got when we get into the material graph, but we'll talk about kind of that layering aspect as well. Okay, so again, if you've got questions while we're working, let's just go ahead and type those in, and then we'll be asking those. Anything that's a little bit more complex, we'll be saving to the end. And just as a reminder, you'll be able to download a lot of these 3D files that we use, the recording, as well as this PDF. And we'll record this and post it to YouTube. So just quick reminder, just in case those questions are coming in. So let's talk about some texture types. And for now, we're going to focus on some of the, I'd say, more kind of common texture types. So these are the ones that you've probably seen before. And we're going to take a little bit of a deeper look at what they are and how they work with our materials. So we usually tend to have, you can see here, color textures, bump or normal textures, roughness textures, which are new for KeyShot 6. I forgot to include specular textures. We'll talk about that one as well, and opacity. So first, let's talk about the color or a diffuse texture. So this is one of the most basic texture types. It simply overrides a material color. So you can apply it to something like metal or paint or plastic. On the left-hand side, we just have a highly reflective 50% gray plastic. And then in the top right corner, you can see the texture that's been applied to it. So we're not affecting the shininess. We're not affecting any of the surface deviation. We're simply saying where there used to be a gray material, we're replacing it with some sort of image texture. But yeah, so color textures are really simple. You can use almost any raster image, apply it, and they even support transparency as well. So in this case, right, here's some examples of some really nice color textures being used. On the left-hand side, our felt material is a really nice high-quality texture that's applied to just a simple diffuse material. So we're not really seeing any reflections, we're not seeing any bump. We're just seeing that instead of some diffuse color, we're actually we're now seeing a really nice image texture. On the right-hand side, with the wood and the tiles. Again, it's like a simple shiny material, whether it's a plastic or a paint, I'm not entirely sure. But the material is really, it's getting its realism through the image textures. Again, you're seeing that really nice appearance of the wood coming through there. So yeah, so those are going to be color textures. They're pretty straightforward. We'll run through that as well. Again, kind of hands-on, but they're going to be the most basic texture type. One of the second texture we'll go through that's, again, pretty basic, but are bump textures. And again, kind of commonly misunderstood. Bump textures use grayscale values to kind of simulate peaks and valleys in your material. You can use any texture, and KeyShot will read the grayscale values in order to kind of interpret the height information. You can definitely bring in specific bump textures, ones that are made with black and white, and they work great. But if you don't have bump textures, then just throw on your color texture and duplicate it as the bump. And we do a good job of reading the grayscale values in order to represent the height. What I mean when I say kind of surface height is something like this. So kind of top right-hand side, we've got this kind of checkerboard pattern. And we don't do displacement. That's a pretty common question. But what you can do is if you actually load this texture in to define the bump on the material, it doesn't actually deform your surface, but it basically creates kind of peaks and valleys on your material. Anywhere that's white in the texture is going to be raised. Anywhere that's black is going to be lower. And then 50% gray is basically like your middle level. So you can create your peaks and your valleys, the kind of illusion of actually deformed surfaces by just using a bump texture. So back to this example right here. Anything that's white is higher. Anything that's black or darker is kind of lower. So peaks and valleys is how I like to think about it. This is just a shiny plastic, no roughness. And it's got one image applied as a color texture, the other applied as a bump texture. But yeah, so now we're going to get those deformations on the surface because we have the bump as well. So here's a great example of some really nice bump textures on our keys. This is an image that I reference a lot in training because in this case, you're not going to necessarily achieve the appearance of those keys just using your roughness slider. We've got to add some bump textures, and we'll get into kind of the specific texture that was probably used to create that really nice effect of a textured kind of plastic. But yeah, also related to bump textures are normal maps or normal textures. As a side note, the term map is used interchangeably with textures. It really just means kind of an image. So if you hear the word texture or map, basically the same thing. Normal maps are a little bit different because those use RGB values to determine the direction that the light bounces off of a surface. These are going to be a little bit more advanced. You can't just take any image and assign it as a normal map. However, there are a lot of different ways to get normal maps, and they can be generated with third-party applications like Crazy Bump or Pixplant, which are two. I haven't used Pixplant. I've heard great things. I do use Crazy Bump pretty regularly. In Photoshop CC, they actually added the ability to generate normal maps from within the filters. If you go to filters in 3D, you can generate bump maps and normal maps directly from any image. So if you want more normal maps, and you've got access to Photoshop in the Creative Cloud, they basically added that as output. So that's pretty nice. But yeah, so normal maps, the way they actually work is they use RGB values, so red, green, blue values, to define the direction that light bounces off the surface. So this image I took from Wikipedia because it's a really great example of how normal maps actually work. On the left-hand side, you can see that that's actually modeled geometry. and then the user generated a normal map based off of that geometry. So on the right-hand side, a normal map has been applied to a flat piece of geometry, and when light hits the surface, we can actually control how the light bounces off of that flat surface using a normal map. So they're going to give you a little bit more control than kind of a standard bump map, but you do have to make them. And it's at first I thought it was all wizardry, but it's just blending those three colors to define the surface normal or reflection normal information. Normal maps will be auto-detected by KeyShot whenever you use them. So over on the right-hand side, that's our material editing tab, and you can see that normally, or by default, whenever you apply a normal map, KeyShot checks that little checkbox. So if you're using them, make sure that's checked. It should be. Also wanted to point out that you can always, if you want to get the inverse reflection, then you can just type in a negative value, so that we can work between both positive and negative values for the bump height. And so whatever was a peak is now a valley kind of thing. In a direct comparison, this is what bump maps and normal maps kind of look like side by side. So normal maps, the pros, it's super easy to create. Bump maps are easier to create, whereas normal maps need some more understanding or specialized software. In this case, you can really see the difference kind of back here and a little bit over here. The normal map has got more of that information, so we see some more interesting reflections because we can really choose the direction that the light bounces off of the surface at that basically pixel level. So again, more control with a normal map versus just a regular bump map. And again, this whole thing is going to be available to download later as well. Another common texture type that we use are specular textures. This one's a little bit harder to see sometimes, but a specular texture defines the specularity or reflectivity of a material. On the left-hand side, we have a 50% gray plastic that is 100% reflective. On the right-hand side, we've applied this texture as a specular texture. We're defining how reflective it is using an image texture. Not all materials have this parameter either, like paint and metal don't. Plastic does, so we have that extra level of control. I mocked up a quick sample here to see what that looks like. So right now we're just using this tile texture that you can see on the upper right to define the color and the bump textures. So we're getting the right color. It looks like it should. And we're using the same image as a bump texture, and it's looking pretty nice. But if you take a look, especially up here, kind of on the left-hand side, everything is glossy. Whereas, or everything is really reflective. The specular component or the reflectivity is set to 1 or white, so it's totally, completely reflective. In real life, the grout wouldn't be reflective. So here's what it looks like once we've added this third texture, the specular texture. We're really controlling the color of the reflections, or how much or how little light they reflect. Where it's light, we see more reflections. Where it's dark, we're seeing fewer or no reflections. So pure black won't be reflective, like in the areas in our grout right here. So kind of a quick side-by-side, totally reflective. Whereas now with that specular texture on top of the bump and the color textures, we're getting a much, much more believable material. So yeah, color bump plus specular textures means you'll get some really, really nice results. Also, next texture, new for KeyShot 6, Roughness Textures. So roughness is historically only been allowed to, or it was only something that you could change on kind of a global material level. Now we can actually determine it using images or procedural textures as well. So with roughness on a material determines really the gloss value, how smooth that surface is on like a micro texture. Anything that's a roughness of 0 means it's super shiny. Anything with a roughness of 0.2, 0.5 up to 1 means it's more kind of matte. So what we can do here is we can plug a texture in to define the roughness. So black is roughness of 0 or totally smooth. White is roughness of 1 or more kind of a matte finish. So we'll do this again. We'll get to this kind of in our hands-on component. But if roughness textures are new to you, roughness textures are awesome. They're definitely one of my favorite additions in KeyShot 6. So in the example here, we just have a metal material, and the only thing we've done is we've applied a roughness texture to it. So here you can see that anywhere where it's black, totally smooth. And in the kind of gray areas, the lighter areas, that means it's rougher. One of the best examples that I can give you for where you find this in kind of the production standpoint is when you have like an in-mold logo. If the mold itself gives you a totally smooth, glossy finish, and then where we put a logo, it's going to be bead blasted. This is a great way of getting that kind of representation. In this example here, we're using roughness textures on both kind of the ground material and then the glass itself in order to replicate kind of smudges. So this image was made again using these high quality image textures, and that's how we're getting that smudge on the glass, because we're saying on that portion it's that surface is a little bit rougher. So yeah, roughness textures, that's how they're going to work. We'll run through it again, but I wanted to give you more kind of a broader overview from an application process. Last texture type that we'll talk about kind of in the presentation, opacity textures. If you've ever done any layer masking in Photoshop, that's kind of what we're doing here. We're determining the visibility or the opacity of a material using a 2D texture. When we apply it, anything that's white is visible, anything that's black is invisible. So in this case, our super slim little box now has holes punched in it because we're determining the visibility of the material using this 2D texture. You don't necessarily have to do it, but I tend to find that when you do use opacity texture, throw on a bump texture or a normal map on top, or a normal texture, because then that's going to give you a little bit more realism. In this case, we're kind of beveling those edges, and you're seeing that surface has a little bit more form to it. So that's a great way to add some realism to your materials. This one is the bump texture, or excuse me, normal texture with opacity, gives us that really, really nice appearance. When this is actually used in a rendering, for example, here on that front grille, instead of modeling something like that, which would be really, really intensive, we can just use an image to define the opacity of the material, in this case, our kind of metal grille. So that's a quick run through of some of the different texture types. Also keep an eye out for this little icon right here whenever you're working in KeyShot. That means it's a texturable property, so we can actually throw in textures to define a lot of these variables. We'll also come back to this one. So we've talked about the different texture types. Let's talk a little bit about the different projection types. Because what we're actually doing in KeyShot, whenever we work with image textures or like a 2D texture, we have to actually project that image onto our 3D geometry. The default is going to be a box map. What we do is we essentially create a cube, and then we use whatever that texture is, and we project it as a cube from 6 sides. So from all 6 sides, it's projecting onto the material. What was a shiny plastic is now a shiny plastic that looks like wood from 6 sides. I got lucky, and this example looks really nice, but those of you, depending on your forms, like if you're trying to do a cylinder or if you have a really organic forms, have probably run into some limitations on the box map. But again, it's going to be the default type where we're just projecting some image, in this case a wood texture, onto our piece of geometry. This is one we definitely will spend a little bit of time with, cylindrical mapping. What we do is we take a 2D image and we wrap it around our cylinder. We've updated this in KeyShot 6, so I would really want to call out that we've added these fit buttons. Those are pretty critical. So we'll talk about that in our kind of hands-on portion. But what we can do whenever we're prepping our cylindrical labels, make those labels one-to-one based off your geometry. You're not going to have very much luck if you're just doing kind of random graphics and then putting them onto some shape. In this case, we have our KeyShot render juice can, and had to do a little bit of math to determine that the height is 135 millimeters and the circumference was more than that. I can't remember. I think it's like 166 millimeters, something like that. But if I know the size of the geometry, I can create the artwork specifically for it, and then it's going to fit one-to-one, and it's magical when it works one-to-one. And so we'll talk about that actual workflow, and we'll use this example a little bit later. Planar projection is another really simple one. I tend to use this a lot. It's we're projecting our 2D image onto whatever our object is just from one direction. This is really nice for things like, like ground or flooring or something like that, because it's going to give you a really clean appearance of those textures. since it's only shooting down from one direction, there's not going to be any Z or X interference if I'm projecting, for example, here on the Y. But yeah, so we'll run through that one. Planar projection is also great for labels. This is another example that we should be able to go through. If you know exactly how your graphic is going to be presented on the model itself on the left. So over here, we have our screenshot from NX. Second image here, we actually have the graphic from Illustrator. And in KeyShot, we were able to use that image, know its actual image size, and then use the DPI functionality to make sure that it's a perfect one-to-one representation. And if your graphic is the same size as your piece of geometry, then it's going to snap perfectly. So hopefully we'll be able to replicate that. Shouldn't have an issue. But when it comes to labels, planar projection is really handy. I do want to mention UV coordinates because that's a pretty big question that we get often. UV coordinates we will respect, but those have to be defined in your modeling software. As far as I know, UV textures can't be defined within kind of your traditional CAD packages like SolidWorks or NX. There are some kind of workarounds where you make one function into, let's say you had a sweep, you separate that as a separate color, and you may get lucky with UV definition. I've been able to do the same myself in NX. But generally, UV coordinates do have to be assigned in your modeling package. Rhino, all the ones you see listed there. We can create UV coordinate definitions. So for example, here with our little squid going to his first day of school, you can see that on the texture that's wrapping around his kind of collar, that the texture is wrapping as it should, and that's because those textures have been assigned in the 3D package. Again, most CAD packages, I hate to say it, but you're out of luck. In that case, we'd use some procedural textures and try to get around it. But if you are using something like Rhino, then take a look at UV assignment, unwrapping and assignment, because that will give you a lot of control over how your textures are wrapping around surfaces. Lastly, normal projection. So when it comes to working with labels by default use normal projection, and we'll run through this. But basically, they are good for your curved surfaces or kind of non-geometric shapes, because we can just kind of click to position it, and it will position it based off of our camera position and information, and we'll run through that one again as well. The big takeaway here, DPI. DPI allows us to create one-to-one labels because we can actually know the real-life size. A couple of resources for textures that I want to mention before we get into it. Our cloud library has a bunch of textures. If you haven't hit the button in the bottom left on the toolbar in KeyShot 6, that's your KeyShot Cloud. And in the KeyShot Cloud library, we've got a lot of different textures there that you can download for free. We also have a bunch on our forum, and here are a couple of websites that I want to mention. I think today I'll be using a few textures that I found there, or that I've generated through an application called Filter Forge. So that's another good one for creating your textures. So let's go ahead and hop into KeyShot. If you guys have any questions, again, please feel free to send them in. If not, we'll take some time for Q&A after the session wraps up. So just to do kind of a quick overview of our different textures here, these are some of the textures that I used in that presentation. We get the question of how to manage textures. You don't necessarily have to add the textures into your texture library, although I sometimes do. One of the easiest way of assigning a texture, two easy ways we can do it. I can actually drag it directly from Windows Explorer or the Finder and apply it directly onto a material. That's really easy. Another way that I can do it is I can actually grab that texture and I can apply it directly into kind of our well or our node right there. And now you can see that that texture has been applied. So these are some examples. So if I select this texture here, I have a diffuse material. I'll just change it to a paint material so it's a little bit shinier. So if I go to the textures tab, you can see that I have this image applied as a color texture. If you hit the drop down here under mapping, this is where we can control the size and shape, or the size and position of our label. If I hit the mapping tool, I can readjust the position of this this texture in 3D space. And you can see here that if I turn some of these elements on and off, then that makes positioning a little bit easier. So for example, if I wanted to make those a little bit bigger, I can type in 5 for the scale, and now that's going to be a little bit bigger. if I, again, go back here and I throw in a bump texture, right? So now by default, those are going to be synced so that whenever I make a change, both of those should update at the same position, scale, everything else like that. So in this case, I have a paint material, I have a color texture, so that's what's making it actually look like wood. And then my bump texture in this case is giving me those peaks and those kind of peaks and valleys for light to bounce off of. Okay, so I'll turn these off just for now, and I want to talk a little bit just for a second. I mentioned it in the presentation, but if you've never messed with roughness textures, these are pretty cool. One way that you can apply roughness textures is we can't drag it directly onto the material here, but what we can do is we can drag it directly onto this little icon that defines roughness. And so what this image is doing, and so we see this better with some contrast, I'll make this paint black. What we're doing here is we're actually determining surface roughness. And again, we got a lot of questions about wood. This is one of the top tricks for working with your wood material. Use roughness textures. Because what we're saying is anywhere that texture is black, it's going to be smooth or shiny. Anywhere it's white, it's going to be slightly rough. So as I rotate the environment around my model, you can see that this is a really interesting way of picking up my shadows and my highlights. Or sorry, just that it changes the gloss. Shadows and highlights are when I throw on a bump texture on top of this. So this one, even without a color texture, is going to give me a really interesting appearance because I'm again defining that roughness using an image. If I then throw the color texture on, right now I'm getting a really nice looking wood material just by throwing kind of 3 textures on. This texture was made using Filter Forge. If you ever get into a scenario where you're missing a texture, like this texture you can see here, I'm getting a lot of reflections in kind of this area, and I want to kind of mask those out a little bit. What I want to control is the specularity or the reflectivity. Well, if I don't have control over the specularity, then I can just change the material type. I tend to use plastic a lot for that reason. If I change this to plastic, my material is going to look a little bit different, but now I can control the specularity or the reflectivity. And again, I can just go back. I can find my specular texture. I can load that in here, and now I'm really defining the reflectivity of that material. So again, I've got now 4 textures that are assigned to this material, and they're giving me a lot more control. So yeah, color texture, roughness texture, a specular texture, and a bump texture. And I could have used a normal texture as well. But yeah, so quick intro to kind of our textures. Again, since these are synced, if I kind of scale these, I can change the size. I can use my mapping tool to reposition them. Let's say I want to rotate these 90 degrees, hold shift to snap it to 15-degree increments. But I can use this in order to get again, more of a realistic appearance by just changing the position, the scale, and key is using multiple textures on all of these. So that's just kind of a simple run through with some of the image textures. Let's talk a little bit about the different mapping types. So in this case, I'll open up, I just paused my KeyShot session, so I'll open up a separate session here because I've got this little can, right? So here's our shiny metal can, and I want to apply a texture to it. So the texture that I've created is this kind of graphic that's going to go around my object. If I go back to my presentation, I think I lost it. Let me open that back up over here. Let's talk about cylindrical projection, because this is really important. If you're working with real life units, and you should always be working with real life units, make sure that your graphic is 1-to-1. For example, here I use the height of the cylinder to define the height of my graphic, and I use the circumference to define the width. Because if I were to unwrap that surface, and flattened it out, that's what it would look like. And you have to plan for the seams. So in this case, I have a seam there. You've got a seam because that's how it is in real life. If we were to put a sticker on it, it's going to be some sort of flat sticker that we wrap onto it. So here's our graphic. And if I want to apply that as a color texture, I can just grab it, drag it directly onto my model. It may struggle a little bit here. This is like a 6K texture. And I can throw it on and apply it as color. And so here, I can see that it's not doing what I want it to do. And let me change this to paint so it's not as reflective. But now I get a texture and it's funky looking. Two things that are affecting that. First of all is the scale. I want to scale this up. And the other thing is that it's using the standard box mapping. So we're seeing clipping and a bunch of weirdness, and that's because we're using a box map in order to scale or to project this image onto this surface. What we're going to do instead is I'm just going to change this to cylindrical projection. Here. Now that magically snapped, and that worked out really well. So that's cool. Part of the reason it snapped with scale is that I built it again 1-to-1, and then since I know the size of my geometry, it's going to stick. The other thing is I also got lucky in that this was modeled in Y up. But what you could do is new for KeyShot 6 is the addition of these fit buttons. So I'll try clicking Fit X, and let's bring up our mapping tool. What that's actually trying to do is it's trying to map it to our KeyShot X axis. Or if I hit Fit Z and bring up the mapping tool, you'll see that's what my cylinder looks like here. But if I hit Fit Y, since KeyShot is Y up, and I go to my mapping tool, you'll see that it's using the cylinder to project onto my surface. So I've just modeled it in a way so that the graphic is actually the size of the piece of geometry. I can hit Fit Y, and then that's basically, it's not magic, it's all math, right? But it's 1-to-1 scaling under the hood. So yeah, that's a quick way of working with cylindrical mapping. If you've got an object that is slightly not perfectly cylindrical, let's say this was a coffee mug and we had a handle sticking out right here, well then you can always use the mapping tool to reposition your cylinder, right? But the cylindrical tool, or the cylindrical mapping tool, is intended for kind of a cylindrical or perfectly round extruded kind of form. But yeah, so that's how we can create, that's how we can assign a cylindrical label onto our part there. Let's talk about planar. Actually, let's hop into procedural textures. I'm trying to keep myself on topic here. I showed briefly a slide full of procedural textures, and what I've got here is this kind of rhino. So here's a really nice model that I got from GrabCAD of a rhino, and I'll double click on it, and let's just change the material type to something like plastic. So by default, that's a glossy white plastic, white diffuse color, white specular texture, and or excuse me, just no texture, just specular, so it's highly reflective. And let's back that down. So now we just have this kind of shiny rhino. So procedural textures, the math-based ones, are not under your textures library. They're actually embedded in the material itself, and that's a big difference. If I want to assign a procedural texture, I have to go to the Textures tab, and then right here where it says None, that's actually a drop-down full of different procedural textures. We have a lot. If I go back to this kind of slide right here, and let me go back a bunch of pages, there are a lot of different kinds. Sorry for the headache of seeing all of those. They're grouped into 2D and 3D procedural textures. The 2D tend to follow the same kind of mapping techniques that your images do. The real power, that, in my opinion, are these 3D textures. Because what I can do is if I go to the diffuse texture here, I can select it, then use my drop down, and let's try something like a color gradient. Now we have a 2-color gradient on our rhino. It's going from black to white. The gradient does respect your scene units. So for example, here this scale is 1 because this was modeled in millimeters. Let's say I want a 20 millimeter gradient. Now I have a gradient going black to white on my object. If I want to throw a third color in there, I can start assigning different colors into my gradient. But again, this is a completely 3-dimensional gradient, right? So I can move this however I want. I can rotate it. I can reposition it. There's a lot of control that you get with these procedural textures. I got a specific question about white on white in kind of the sign up form. I'll delete this color gradient. Actually, I'll just delete it here. If I change this to a color gradient, and right now it's just set to black and white, I'm back to my defaults. Instead of using a planar gradient, just kind of like in Photoshop, you can change radial, circular, whatever. I can change it to view direction. What this allows me to do is it controls the color based off of my viewing angle at this material. So I'll turn off shadows with the S key. But now any surface that's pointing directly at my camera is red, and as that angle moves away, it goes white. This is a really nice way of being able to add some richness to your white materials. Because if I set this to white on white, it's totally, it's a little bit more blown out. Whereas if I apply this texture to it, I now have 2 variables to define the color. Or if I throw in another color stop, now I have 3 color stops that are helping define that. So the color gradients are incredibly powerful. They're a great way to work, and a camera-based one is a really good one. Another procedural texture that I use a lot is, I'll get rid of my color gradient here, is noise. So if I use the drop down, change this to a noise texture, you can see noise is just kind of a black and white noise. So it's a bunch of randomly generated dots. I tend to throw that on my bump texture a lot. And let's change this material down to dark. Because if you want to add some kind of subtle imperfections to a surface, adding a bump texture is a good way to do it, and procedural noise is perfect for this. Because most materials aren't perfectly smooth and glossy. And that was also some feedback that I read in the sign-up sheet. Adding something like a noise texture to the bump will allow you to, actually add in some really nice fine textures. And then if I throw in some roughness, that will randomize those reflections a little bit more. But now we've got a really, really nice finish on this surface, again, because I'm using that procedural bump texture, which really adds a lot to it. So that's another procedural texture that we can use. We have a bunch. We don't have enough time today to go through all of them, but they are really powerful, and I recommend you checking it out. Another one that's really useful is leather, and one that I want to mention here briefly is wood, because again, we got a lot of questions about wood. Whenever you're working with a wood procedural texture in KeyShot, you really have to think about what's happening with the material itself. So if I take a look at this, here's just a quick screenshot, but this is, if you can imagine, just like a KeyShot tree, right? Or this is actually a representation. I'm trying to recreate an image that I saw of how lumber is cut. In this case, we have a tree that grows straight up, and then we chop it into a bunch of pieces. And all those pieces really determine the grain structure that we get, whether it's end grain or whether it's quarter sawn, or what we're actually seeing. So whenever you use the wood procedural texture in KeyShot, so here I will go back and I'll go to my diffuse texture, and let's load in wood as that texture, and let's scale it up so we can see it a little better. This is the advanced wood. There's also a basic wood. But what you have to do is you have to imagine that with my mapping tool, this wood is actually growing out of the center of my geometry. The wood is it's a series of concentric cylinders. So you can see here, that's like I were to have just taken this rhino and carved it out of one solid chunk of wood that was right in the middle. If I use my mapping tool, let's say I rotate this 90 degrees, and then I move the center point out a little bit. And now if I look at that texture, again, turn off shadows with S, my center point is over to the left of the model, and now I'm getting a more accurate representation of what the wood would actually look like, right? And I can always reset that, hit the little reset button right here, it'll snap back to the middle. But yeah, so whenever you do work with a wood texture, you do have to think about how or where that texture is actually, assigned in 3D space. Think back to that image that I just flashed up right here. Where is your chunk of wood coming from in the cuts, right? So that's what it's going to look like. So that's a little kind of primer on working with a wood texture. It's going to be brief because this is kind of a big overview. But yeah, use that, load it in as bump. And then a lot of times I'll also load it in as roughness. And here's kind of a cheat. If I click on this little icon here, I can right click, go to my textures, I can add wood advanced, and now that texture is also defining the roughness on my surface. Right, sorry about the background noise. But okay, so we've talked a little bit about the wood. I wanted to make sure to introduce that to you as well. So let's talk a little bit about labels, because labels are also going to be pretty important. And again, it was something that you guys specifically wanted to address. Let's take a look at, first let's take a look at planar projection for a label. And I'll open up this file right here. And here's just kind of a quick calculator that was modeled. If I want to assign a label onto a material, there are a couple different ways. First, let's do kind of a generic label. I'll double click on this material to edit it, and I will change it to a plastic material. I'll keep the specular to white, which means it's going to be nice and shiny. Well, I can take any raster image, especially ones that have PNGs or have transparency like this PNG, and I can drag it and I can apply this as a label, and it's going to snap onto my piece of geometry, and only that piece of geometry, because currently it's the only one that has that material assigned to it. I'll just call this, let's say it's shiny plastic. All right. Fighting with spelling and caps lock today. Okay, so plastic. There we go. All right, so if I go to my materials, now you can see that this label has been assigned onto this piece of geometry, and I can scale it down, right? But the way by default the labels are going to project onto my surface is using normal projection. Normal projection uses 2 points of reference. One, wherever you click on your model, it's going to use that as the center of your label. So that's one variable, where it's clicking and what the shape of the geometry is. The other important thing is my camera angle. Watch what happens if I line up my camera so I'm looking kind of dead on. Take a look at the color of the image itself, that gradient. It's lighter over here and darker over here, but the image itself looks like it's rotated. That's because if you use normal projection, it's going to be based off of your current camera angle. So you're going to want to line it up, and you can always go to the camera tab and use your kind of standard views. But whenever you're working with a label, your camera position is going to be one of the variables that's very important. So again, here, if I want that to line up perfectly, I could go up to camera. We'll use one of our standard views. We'll use a top view. And now when I hold the middle mouse button, pan, click position, now I know it's going to be perfectly lined up. Another thing that you may run into when working with labels is going to be either the labels clipping with a very curved, smooth surface, or if I scroll down here, in this case, let's say I was losing some of the texture or this label, right? I'm not seeing it over the edges, and that's because there's a slider for depth. This slider controls how far into the surface that label is being projected from the point at which we click. This slider is unit aware, real life units. So if I type in 0.1, it's going in 0.1 millimeters. If I type in 1, the default's going in 1. If I type in 5, now we'd probably see this label on the back. There we go, because those were shelled out, right? So there you can see the difference. If I decrease this, right, it stops after 1 millimeter. But that's a big takeaway with the labels. And another big thing with labels is the DPI checkbox. If you know the size of the label, just type in the DPI value, and that will be a one-to-one representation of the label. Okay, so we got to get moving here. So let's talk about the different projection type, planar projection, which I use a lot. So I'm going to double click on this material. We'll add a little bit of roughness. Now that we know about the bump textures, we'll throw in a little bit of a noise texture, and we'll scale this down and scale the bump height up. So now we're getting a really kind of smooth, subtle kind of texture on that surface. So let's go ahead and load in the label on it. Again, the label was specifically made to match this artwork. And the image I've got somewhere down here, right? If you know the size of your geometry, make the artwork to match. So here, I know the size of my geometry. In Illustrator, I made that artwork. So now, if I just, if I double click on my material, I can go to the labels. I can add a label, and let's go find that label. I tend to have better luck when I add it this way for planar projection. So I will select my label planar calculator. Let's apply this one. And instead of messing with normal projection at all, I'm going to hit this little red X, and then I'm going to change it from normal projection to a planar projection. And let's try planar Y. Planar Y, if I go up to view, if I show my coordinate legend, that's our up, down in KeyShot. So now it's in the right direction. All I need to do is flip it. and that just has to do with my surface normals. So let's just reset this, set the scale back to 1. Okay, so the issue I'm running into here is sizing, right? So I reset it and it looks a little weird. DPI, I forgot to define the DPI. When I exported this from Illustrator, I exported at 1000 DPI. So I should be able to just type in 1000. It's not working here. Let me just try re-adding it. I'm not sure what I did in the process there, but I'll throw this in, right? Let's use planar Y. Type in a DPI value of, again, 1000. Scale goes to 1, and then now I can just flip it. And now that should be right where I need it, right? So that's a great way of just kind of quickly assigning the that label. It's going straight down onto my part. It's in the right position, and it's at the perfect scale. If I were to copy this material by holding Shift and clicking, and then Shift and right-clicking to my other parts here, you can see that that label has been perfectly applied to all of those other parts. And that's because it's using one label to define them, and that label was created kind of in the global space. Now I can just change these colors, get close. It's not going to be super close, but now I had unlinked material, so I can tweak these, right? And I'll change this to solid glass, and then now I've got my really simple calculator. So we'll make this one available as well. But yeah, so that's how we can work with planar projection and controlling the scale and placement. So that's a really easy way to do it. Okay, so we've covered our planar projection. I'm moving through this because there's a lot of content. So again, if you've got questions later in the Q&A, we can get through some more of your questions. Let's talk about kind of building up layers of labels, because that's something that people really want to do. I've seen a lot of requests for that. So here we have a can really similar to the one we had last time, and I can copy and I can paste the material onto kind of my, so I'll copy this material and I'll select this part and I'll paste the material, not a linked material, because I want to just kind of set a baseline here. So now I have that one part with that one material assigned to it, and let's add a label for it. So let's talk about the labels that were created. Well, first we have a label that's going to be kind of our layer of paint. And then we have what's going to be another layer. We can make that into chrome. We've got one for our printing, right? Our color here. And we have a bump texture as well. And so what we can do is we can start loading these onto our graph, our part right here. So if I just grab this one, my label 1, and I drag it over, I can apply this onto that metal material, and I can apply it as a label. And you can see by default, it tries to go to normal projection, which we're not going to want. Instead, I'll use my drop down, change that to cylindrical. And I'm going to double check and make sure that my cylinder is in the right orientation. Looks like we're good. Again, because I made that graphic one-to-one for this model. So that's pretty key. Okay, so now that we have that label applied, it's a plastic material. Let's say that plastic material has a little bit of roughness. So there we go. It's got some roughness. Well, now we want to start applying the other layers on top of it, because I've broken those out as different layers from Illustrator. So I can select that label. I can duplicate the label. So now I have two of the same labels stacked on top of each other. But for the second label here, I'm going to redefine the texture. So instead of using this blue label, I'm going to go find the other image that I use. So let's go back here. Let's go into our label layering. Let's find can label 2. And now it's going to keep the same position and scale information. As soon as that reads, there we go. Now we have our second layer of label, and I'm going to change this material to metal, right? So now we have a layer of the metal material on top, and we're isolating it using this. Essentially, we're using our label to kind of mask out where we see it, right? And for this one, I'll get rid of the roughness. So now we just see a nice, smooth, sharp metal. Okay, and then I want to put my graphics on top of it. I can use the same trick, so I don't have to move or reposition it. I can duplicate that label, and then for what will be label 3, I can hit my little folder icon and load in can label 3 color, and then it should be magically applied in the same place that my other labels were. Yeah, if I turn it around, boom, now we're good. And then for this label, I can throw in a little bit of roughness, right? Or I could do whatever I want. But again, cylindrical labels are going to be achieved by making sure that your label is the same size as your piece of geometry, and then just using the mapping tool on top. So that's the trick for working with cylindrical labels. And then the kind of layering is done just by duplicating them and then replacing whatever the image was. For all of these separate layers as well, for all of these different materials, I can add bump textures to them. So for example, this second layer here, these kind of are icons. Let's say for this, we throw on a noise texture. Right, so now that's going to have some kind of waviness to it. I don't know what the treatment is there and the material itself, but that one's got some interesting stuff. For this color texture, let's see, hopefully I saved the right file. We're about to find out. Nope, I saved a Photoshop file from the looks of it on top of that one. Oh, it worked. Or something happened. I think I may have saved it correctly. But what I did in Photoshop is for that label, I just added a slight bevel using the layer properties. And so now that label also has an additional bump on top of it, and I can decrease that bump height. But now it's getting some actual form because of the bump texture applied to it. But yeah, so there we go. Now we've got our kind of fancy label. It's all layered up with different materials, right? And then some have different bump textures, and then we can apply them that way. But yeah, so that's how we can work with our cylindrical labels, layering them, adding materials to them, add textures to those materials. So that's it for kind of the label portion. So I know we want to talk a little bit about the material graph. So I'm just going to take a quick check on time. We're almost at the hour. So I'll do just kind of a really brief intro to the material graph, and maybe if you have got further questions, just go ahead and type those in, and then we can start addressing some in the kind of Q&A session. But the material graph is a KeyShot Pro feature, and I'm just going to go back to this Rhino right here, and we're going to let's make some tweaks to this material. I'll change this to kind of a basic chrome. But the material graph is where we can start making or having more control over our materials. So what I mean by that is, let's say if I were to throw in a little bit of a texture onto this material here, and that's actually pretty good for scale, but now I've got a bump texture on my material. Let's add a little bit of surface roughness, and let's back out on the color so it's not as reflective. But yeah, so now I have kind of like this matte black metal. Well, let's throw a label on top. If I go to my textures, I can use that same icon, drag it over, apply it as a label. Normal projection is okay for this. I'll just scale it down. I don't know the DPI because I didn't make it, but now we have our logo on it. So it's right there. By default, your labels are going to be a plastic material. Let's change that to metal. So now we have metal on metal. Let's duplicate that label by holding Alt when we drag. Now that metal has a bump texture, and let's add a little bit of roughness to it and back down on the bump height so it's a little bit softer, right? So now we've got a little bit more interesting thing going on. Well, so far we haven't done anything too crazy, and we haven't needed the material graph. But what is the material graph? Well, if you're ever working on a material, and the material graph is specific for any material, you can use the material graph on any material, but it's specific to the material. I'm going to get out of full screen mode by hitting F, and I'm going to hit this button here. This shows me my material graph. This is a visual representation of the material that I've created so far. You essentially have a parent material, and then we have all of these other nodes that are defining that parent material. So if you're kind of intimidated looking at this, I certainly was the first time when I started playing with this, but it makes a lot of sense. What we've done is we've taken our kind of basic material editing tab here, and we've turned it into a node-based material editor. We have all these different nodes. So all these little parts here are nodes. and they're all connected together with these blue lines. And what we're saying is we're essentially creating a flow chart for a material. Our material is made up of all of these nodes. These nodes have outputs and inputs. So for example, here, the noise texture I'm using as an input to define the bump texture for my metal material. So we've got that. My metal is really just my label that I've assigned a metal material to, and that label is being defined by a color texture and a bump texture. And if you double click on any node, you can see that node's properties. So for example, here's that node, and here are the two textures that are defining it. So it's really related to what we've been doing this whole time. Just behind the hood, we have more advanced control over it. Anytime you're working in the material graph, you can right click an empty space and we can add on new nodes. So we've got 4 basic types. We have materials, we have textures, as you can see here. We can animate properties, and we can use utility nodes. So these are modifier nodes. We can use these to combine or change some of our nodes or textures. So let's say, for example, here, if we wanted to change the color of this icon or desaturated it, it's too blue, we want it to be a little more moody. Well, I can right click an empty space, go to my utilities, and I can throw in, for example, a color adjust node. And if I double click on it, you can see here, these are my color adjustment properties. And right now it's free floating. It's not attached to anything. So I'm not going to see any results. But what I can do is I could use it as like an interrupter or a modifier. And I'll take this output that was originally defining my label color, right? And I'll plug it in to define the color of the color adjust. And now for the color adjust, I'll take the output and I'll plug it in a color. And now you can see, if I hit this little cleanup button right here, you can see that the color adjust is modifying my color texture. Well, now if I double click on color adjust, I can start making changes to that label, and you can see it in real time. For example, I can desaturate it and I can bring it back to the original color, or I can slightly tweak the color. But now something that you used to have to go in a Photoshop to do. You used to have to go in a Photoshop to change the color of a label or a texture. Now we can start doing it in the material graph. And again, our utility nodes will help you with that. Another really common one that tends to get used, or it's one that we get a request for a lot, is multiple bump textures. So let's say we wanted to add 2 bump textures onto this material. Right now it's got noise, but let's do the old scratches, right? So now if I right click and I go to my textures, I can see that I have scratches here. And right now my node's not connected to anything. So what I want to do is I want to combine 2 bump textures. So I'll right click, go to my utilities, and I can go to bump add. Now I can see that I have bump add. Bump add takes bump 1 and bump 2 and spits out an output. So I can take the scratches, plug it into bump, let's say bump 1, and then now I can take my noise, pull it, decouple it from metal, plug it into bump 2, and now if I take this output and plug it back into my metal material, now I have noise plus scratches using my bump add, bump 1 plus bump 2. If I double click on this node, I can make changes. I can change the ratio between those 2 bump textures, or I can weigh one so that I see one more visible, right? But yeah, so this essentially bump add takes both of those, creates a composite, and pushes it through on the bump. Really handy thing whenever you're working with the material graph, and this will sadly have to be just kind of an intro. But if you ever double click on a node and you're modifying that node, you can preview just that node. And the preview icons are up here. I can preview the color. So that's what my scratches look like with no texture, with no reflections, nothing just other than the graphic representation. Right, so here I'm seeing the color. If I change this to alpha, I don't see anything because it doesn't have any, alpha. Let's see, I'm not seeing bump. Oh, that's because very interesting. Weird, I should be able to hit B and bump. Nope, for some reason, I'm not seeing that, that bump texture, but you should be able to preview the bump as well. Probably something on my side. But yeah, so this is a good way of being able to preview those nodes. For example, here I can hit color. This one I can hit color. That's what the noise looks like without actually having to be rendered. That's what that texture looks like. But your previews are up there. They're really, really handy. But yeah, so now I'm using two utility nodes, a bump add and a color adjust, to make some changes on those. This is awesome, the material graph, because you can take this in basically any direction. My recommendation: find a use case and try to replicate it. Like that image I showed earlier with the glitter on glass. That one, I don't know if there's a fast way. All right, there we go. That is a fast way. Excellent. So for example, here, the request that I got was we have a plastic material that basically has metal flakes in it. Well, what I did here is I created a clear kind of glass and then added on layers of metal, and then used, in this case, a spots texture as the opacity texture to knock out where it was visible on that material. If we wanted to replicate something like that, just because I want to show you another way that you can use labels is essentially as a layer of material. Let's say we're going to add some really shiny glitter onto this rhino. He's going to look beautiful by the end of it. I can right click an empty space and I can throw in a material, and I'm going to throw on a metal material. And if I click and I drag this directly onto my parent material, now I've essentially coated this whole material that I had made with another layer of metal, because it's on the top layer. If I change this to red, we can see now all we're seeing is our red metal. So let's do a really quick color gradient here. So now we see two different colors, and I'm going to change this to a view direction, so we'll get a more interesting kind of blended color, right? So that actually looks pretty cool. So now it's my metal material that's being defined by a color gradient, and now I want to mask it out. Let's say we only see certain spots. So I'll right click, I'll go to my textures, let's throw in a spots texture. If I double click on it and hit C, now you can see a preview of those spots. If I use this to define opacity or transparency, right here, right? Let's go back to kind of our reminder slide. White is visible and black is invisible. So as you can see here, my main part was white, my spots were black, which is why I'm seeing through them. That's if I wanted to actually, make holes in this layer of metal. But in this case, I want the metal to be visible. So two things I could do here. I could either go in and I can change these two colors, I can invert them, or again, I can use a utility node like color invert. This makes white black and black white. I can now throw the spots into my color invert. So now if I double click on it, now we have white dots on a black background. And when I plug this into my opacity for my metal, we see little metal dots all over our other metal material. And I'm pretty sure on my example as well, I threw in one of the procedural textures. I think it was, in this case, if I go to bump, pretty sure it was cellular, because cellular gives you some more interesting reflections. It's like a bunch of cells, right? So something like that, right? So all of those little spots of glitter are pointing in the reflections point in different directions. Okay, so now we have a much more advanced material here. If I go to the labels, you can also see the representation of those labels. One thing to make note of, right now my glitters are on top of my KeyShot logo. This list of labels here is going to respect layer order as far as visibility goes. If I want to put the metal flakes below the logo, I just hit the down arrow, and now it's below it. So yeah, that's another use case for the material graph, basically layering materials. So I'm going to go ahead and wrap this up because we're 10 minutes over, and my apologies for going through it. But that's kind of a quick primer to the material graph. There's a lot more to it. There are more utility nodes. My suggestion is play around with it. But whenever you play around with it, have a use case in mind. Try to create something like that example of the crazy material with the glass with the metal flakes on it. I won't toggle back to it right now. But we'll go ahead and open up for Q&A. I'm just going to wrap up for the recording. If you have any questions, definitely stick around for the Q&A. Otherwise, thank you very much for listening in and paying attention today. That's highly appreciated. Definitely watch this video again if you want to on our YouTube channel, keyshottcom, or excuse me, youtube.com/KeyShot3D. You can also follow us on all sorts of social media. But yeah, so this session here, we were talking all about KeyShot textures and labels. And again, my name is Richard Funnell, responsible for training, on-site customer training at Luxeon, makers of KeyShot. But otherwise, thanks for attending.